0. Okay. Let's go ahead and get started, since now we're starting recording. So, good morning, everyone. Hope you had a good weekend with the exam. So quick spoiler-free thoughts on it. Anyone? Okay. All right. Good Monday morning crowd. Like, yay, nay, okay. Okay. I mean, seeing some thumbs up, I saw one sideways thumb. Any down thumbs? Thumbs down? Okay, there we go. We got one thumbs down. Alright, so yeah, that's about all I can say with the exam for the moment, because not everyone has completely taken the exam yet, so I'm waiting for the course coordinator to give the green light to be able to say, okay, everyone's taking the exam, now we can start talking about specific questions. So, for now you'll have to wait until that happens, so I will let you know when that happens, or she will let you know. So, okay. So, aside from that, though, there's not really much in the way of announcements. I have office hours tonight on Zoom. There's no quiz this week, but I'll let you guys know more details about that on Wednesday and Friday, but that's going to happen next week, so we won't worry too much about that now. So, let's go ahead and talk about the warm-up. So, for those of you watching online, you can go ahead and pause the video for a second to do the warm-up. Okay, so for those of you that did the warm-up, what did you end up with as your derivative? Go ahead.
2 and then 2x cubed plus 5, and then it was plus 6x squared.
Not quite. So, what I would recommend first for those that, so has anyone else tried this first before let's give someone else a chance, because
So I had 24x to the 5th plus 60x was
bingo, that's what I was looking for. How'd you get that? Factor it out, good. Because remember, this is just 2x cubed plus 5 times 2x cubed plus 5. Okay? So if you FOIL that out, we have 4x to the 6th plus 20x cubed plus 25. So if you differentiate that, we have y prime equals 24x to the 5th plus 60x squared. So just a quick little application of the good old power rule. So, any questions on that? Alright. So, the good news is that with this warm-up, the power on 2x cubed plus 5 was relatively small, so we could just, factor it out, do the usual power rule, and then that's the problem. But here's the thing. Unfortunately, not all functions in math are nice like that. Because what if you have, say, 2x cubed plus 5 to the 22nd power like we have here? Or negative 7? Or square root of 2x cubed plus 5? So let's focus on this one for starters. So if we have 2x cubed plus 5 to the 22nd, well, what would be the problem with that if we apply the derivative rules we know up until this point? So could we basically do what we did on the warm-up for this function? Theoretically. Theoretically we could, but realistically do we want to? No. So basically the problem is that expanding out either not optimal or not an option. Okay, so because of that, we need another derivative rule, and that's where chain rule comes into play. need chain rule. So, today's goal, well, we're going to use chain rule to find derivatives of compositions of functions. Okay. So let's take a look at what I mean by that. So if you recall from pre-calculus or whichever calc or math class you would have seen this in high school, then a composition is going to look something of the form f of g of x. Okay. Now g of x is basically going to be what's called the inner function. Inner function. And the outer function, meanwhile, is just, well, that would be f of x, but I'm just going to put a little squiggly line over the whole thing to indicate outer function. But I'll just put a little dotted box there to indicate, f is sort of the outer function in this case. So what that means is this. So if we were to take some number x, what this says is that if we ultimately want f of g of x, then ultimately we have to put x here through g first, then f. So what that means is that we have x, feed that through g, you're going to end up with g of x, which we're also going to denote by u for our purposes, that you'll see in a minute. Okay? But meanwhile, if you, in turn, feed this through f, then you're going to end up with f of u equals f of g of x. So like I said, if you have some x and you want to ultimately get f of g of x, first feed it through g, then feed it through f. So just a quick little review from pre-calculus. So now let's go ahead and use that reasoning to identify the inner and outer functions for the following. So for part A, I'm going to help you guys out with this a bit, just so you have an idea of what's going on with this. So for part A, we have, let's take a look at what we have. So what we notice is that this 2x cubed plus 5 expression is sort of inside something to the 22nd power, right? So 2x cubed plus 5 is quote-unquote inside something to the 22nd. So what that should tell you is that means that your inner function should be equal to, well, u equals g of x should equal the 2x plus 5, because that's the inside function in this case. So 2x cubed plus 5. Okay. So that will give you your inner function. So as a result of that, that should tell you that if you let u equal this 2x cubed plus 5 thing, what you'll notice is that f of u then becomes, well, u to the 22nd. So in this particular case, that should pretty quickly help you figure out what the outer function is. Okay. So I wasn't sure if you were stretching or you had a question, but okay. So if that's the case, then that should pretty quickly help you identify the outer function. Outer function is, in this case, f of x. Just replace u with x, and then you just end up with x to the 22nd. Okay, so that's all good and all, but let's just for the sake of consistency make sure that we end up with the original function back if we focus on f of g of x. So we have f of g of x is equal to, well, we have f of g of x, which we already established to be f of 2x cubed plus 5. So then now all we have to do is just replace x here with 2x cubed plus 5, this expression here. So we have 2x cubed plus 5, all raised to the power of 22. So that does give us back the original function we were looking for here. Okay. So any questions on that part? All right. So now let's apply the same reasoning on parts B and C. So first off, if we apply the same reasoning that we did in part A, then what should our inner function be for 3 times cosine of e to the x? So u equals g of x, which equals what? Yeah, just e to the x, right? Because in this case, e to the x is inside cosine, so that should pretty quickly tell you that the inner function is e to the x. Okay? So if that's the case, that says, all right, well, then f of u should then end up equaling 3 times cosine of just, well, u. Cosine of u. So that should pretty quickly help you determine that the outer function is f of x, which equals what? Because I have x. Good. Okay. So that's part B. Now part C, it's going to look pretty similar in terms of what we're doing. So for now, I'm just going to focus on what the inner and outer functions are. So one thing I'll mention before we actually do part C is that one thing to note here is that we have e to the power of 3 cosine of x. So one thing that could help you to sort of distinguish the inner and outer functions in this context is to sort of think of this e here as the exponential function of 3 cosine of x. So if that helps you determine what your inner and outer functions are, one good way to write e to the something is the same thing as this. So it's just something that some mathematicians like to do. So okay. So now let's just focus on the inner and outer functions from this example. So the inner function is So what would the inner function be here? Let's give someone else a chance. Raise your hand if you have the inner function. Anyone?
3 cosine x.
Yep, 3 cosine x. Good. And then the outer function would be?
E of x.
Good. Okay. So any questions on that part? Right. So it's good and all that we have that established, but now let's actually focus on, all right, well, what is this chain rule thing you're talking about here? Well, I'm glad you asked, because that's the next thing we're talking about. So, using Leibniz notation, oh, I should actually pull this up a bit. 1 second. So if we were to use Leibniz notation, that sort of gives us the following. So we have y prime equals, well, we already have dy over dx, but there's another way we can write this. We have dy over du times, well, du over dx. So at first you're thinking, what the heck is this? That just seems like you're dividing and multiplying by du, right? Well, kind of, but not really. So let's sort of deduce what is sort of going on here. So what the red part is saying, okay, you're taking the derivative of the whole function with respect to, well, sort of the inner function in this case. So derivative of y with u as a variable, and then du dx, meanwhile, is just the derivative of u with x as the variable. Okay? So that's all that means here. So to give you a slightly better representation of that in terms of what we'll need to compute here, we say, all right, let's let u equal the inner function g of x and y equal f of g of x. What this says is that we have dy over dx is the same thing as f of g of x prime. That's the same thing as, all right, well, you can also write this as, well, f prime of u. So that's what we're saying with this part here. So we're taking the derivative of the outer function with respect to our inner function, and then times the derivative of the inner function with respect to x. So, in short, that sort of gives us the chain rule, which is also written as f prime of g of x times g prime of x. So that's going to be your chain rule that we're going to need for today's lesson. Okay? So any questions on that? Alright. So now let's apply this to example 2 here. So we're asked to repeat the warm-up using the chain rule. So I'll go ahead and write the function here just so that way we have it. So 2x cubed plus 5, quantity squared. So in this case, for these types of problems, let's go ahead and construct a sort of roadmap here. So first off, we're going to need to identify the inner function and outer function here. So what would our inner and outer functions be equal to here? Go ahead. Yep, 2x cubed plus 5, and outer is x squared. Okay? So, a quick application of power rule will then give you the corresponding derivatives. So, g prime of x is just, well, 6x squared. And f prime, meanwhile, is just 2x. Alright? So the good news is that we already have g prime of x as per what we need for the chain rule, so we'll just go ahead and leave this as is. But for the next part, we need f prime of g of x here. So we need f prime of g of x. So that just means we need to replace whatever we have as x here with g of x. So if that's the case, that should tell you that f prime of g of x is 2 times what? Well, g of x we already established is 2x cubed plus 5. So we have just replace x here with 2x cubed plus 5. So this would be your f prime of g of x. So So that takes care of that. So what that tells us is that if we were to put this into our derivative and our chain rule formula, well, we have 2 times 2x cubed plus 5. So this is our f prime of g of x. And then this is our g prime, so 6x squared. So then g prime of x. So this isn't wrong, but just to make sure we're all on the same page in terms of, what we had in the warm-up, let's go ahead and clean this up a bit. So what we notice is that we can multiply 2 and 6x squared to get 12x squared times 2x cubed plus 5. So then if we distribute 12x squared into 2x cubed plus 5, we have 24x to the 5th plus 60x squared, which is exactly what we got in the warm-up. Okay, so any questions on that? All right. So now let's go ahead and do the same thing with example 3 here. So now we need to differentiate y if y equals 1 over e to the 2t. So in this case, this is a function we can differentiate based off of, well, in this case, technically quotient rule and chain rule. But just to condense things down a bit, it might help to rewrite this a bit. So one way we can rewrite this is to say, all right, 1 over e to the 2t is the same thing as e to the what power? Negative 2t, good. Alright, so then if we construct our good old road map, now in this case we're going to have, well, because t is now our input variable, we have to use g of t here and f of t here. So in this case, g of t is the inner function, and f of t is the outer function. Alright, so what would our inner and outer functions be here? So raise your hand if you have the inner and outer functions. E to the t, but so then if we take their derivatives, well, g prime of t is equal to negative 2. And then f prime of t, well, if you take the derivative of exponential, that's just
E to the t.
e to the t, good. So e to the t. So that should tell you that, well, f prime of g of t is then equal to what? E to the so what would f prime of g of t be? Negative 2t, good. So in this case, we'll multiply this function here with this. Alright. So then we plug this into our good old chain rule formula. We end up with, well, e to the negative 2t, which is f prime of g of t, times negative 2, which is g prime of t, which is then just, well, not much you can simplify here. We just have negative 2 times e to the negative 2t. Or if you prefer to write this with respect to this notation here, you can just rewrite this as negative 2 over e to the 2t. So in this case, both of these are acceptable answers. All right? So any questions on that? All right, so now let's look at example 4. Okay. So now we're asked to differentiate 5 times the fourth root of r squared minus 3 to the divided by x squared, where r is constant. Okay. So in this case, let's go ahead and do our usual roadmap. F of x is the outer function. Alright, so what would our inner and outer functions equal here? If we have 5 times the fourth root of r squared minus 3 divided by x squared. I'm gonna start picking on people if people don't raise their hands. So does anyone have the inner and outer functions here? Any ideas? Anyone else have any ideas? What would our inner and outer functions be here? Yep.
Your outer function would be the 5, and the inner function would be the fourth root of r squared minus 3 over x squared.
Not quite. So the one reason I have parentheses here is sort of to denote the fact that we're multiplying 5 times the fourth root of dot dot dot, right?
So then it would be the inner function would be the r squared minus 3 over x squared still.
Yep.
But the outer function would be the fourth root.
Yeah. Well, 5 times the fourth root, but yeah. So 5 times the fourth root of x would be your outer function in this case. Okay. So in this case, now we have our inner and outer functions, but let's go ahead and rewrite them a bit just so that way we can apply the power rule on them. So we have g of x, well, that's just r squared minus 3x to the negative 2, just sort of as what we did in example 3. But the outer function is just the same thing as 5 times x to the what power? 1/4, good. So then, let's see. Now let's go ahead and differentiate these. So we have g prime of x and f prime of x. Well, let's see. So g prime of x, that's equal to what if we differentiate this guy? Yep.
2r plus 6x to the negative 3.
Careful. Remember, r is constant. So if we differentiate a constant, that's just 0. So in this case, this goes away if you differentiate this. But otherwise, you're correct. So we have 6x to the negative 3 or if you prefer, 6 over x cubed. So this will be your g prime of x in this context. And then f prime of x, meanwhile, would be what? Yep. So 5/4 times x to the negative 3/4, or if you prefer, 5/4 times x to the 3/4. So then f prime of g of x, well, just replace x here with g of x. So here, so we have, in this case, 5/4 times g of x, which is r squared, minus 3 divided by x squared to the 3/4. And in this case, this would be your f prime of g of x. Okay. So roadmap is now established. So now, let's see, y prime then becomes, well, we have 5/4 times r squared minus 3 divided by x squared over 3/4, or all to the power of 3/4. This is your f prime of g of x times 6 divided by x cubed, so that's just g prime of x. So in this case, if you put everything together, you end up with, well, 30 divided by 4x cubed times r squared minus 3 divided by x squared to the 3/4. Or if you prefer to simplify this a bit, you have 30/4, which is the same thing as 15 halves x cubed times r squared minus 3 over x squared to the 3/4. Okay. So that would be your derivative in example 4. Alright. So any questions on that? Alright. So now let's do the same thing with example 5 here. So in this case, we're asked to differentiate y equals 3x squared divided by 2x plus 4, all raised to the power of 3, and evaluate it at x equals 2. So now let's construct our roadmap as we've been doing. So in this case, g of x, inner, and f of x is outer. So as you probably have sort of deduced by now, you can probably guess that the inner function is 3x squared over 2x plus 4, and the outer function would be x cubed. So if we were to differentiate f prime of x, well, that's just, power rule. That's just 3x squared. Nothing too crazy with that. But what about g prime of x? That's going to be a bit trickier. So how are we going to differentiate this guy? What rule do we need here if we have one function divided by another? You're going to need quotient rule here. So if we apply said quotient rule, well, we should end up with what? I'll give you guys a head start. Divided by 2x plus 4 squared. There's your hint. Okay, go ahead.
6x times quantity 2x plus 4 minus 2 times 3x squared.
Yeah, could you repeat that a bit slower?
Sorry. 6x times quantity 2x plus 4 minus 2 times quantity 3x squared.
Okay, right. So in this case, if we have low d high, so we have 2x plus 4 times derivative of high, so 6x, minus high, so 3x squared, times derivative of low, so 2. So that gives you the numerator of your difference quotients. So if we were to condense everything down and simplify, well, we would have, well, 2x plus 4 quantity squared, but then what would be on the numerator? Go ahead.
6x squared plus 24x.
Yep, 6x squared plus 24x. Okay. So that will give you your g prime. And then, well, f prime of g of x, well, is just 3 times what? Well, just replace x with g of x to get 3x squared over 2x plus 4 quantity squared. So that would be your f prime of g of x. So roadmap is now established. So now we just plug it into our good old chain rule. So we have f prime of g of x, so 3 times 3x squared over 2x plus 4 quantity squared times g prime. So 6x squared plus 24x all over 2x plus 4 quantity squared. Okay. Okay. So now, the good news is that we have our derivative. So now let's go ahead and evaluate it at x equals 2, because, well, the problem wants us to do so. So we have y prime evaluated at 2 equals, well, 3 times, let's see. So we have 3 times, well, so if we plug in 2 for x, we have 2 squared, so that's 4. And then if we plug in 2 down here, we have 2 times 2 plus 4, so that's just 8. So quantity squared. And then plug in 2 here, we have, well, 6 times 2 squared is 4, plus 24 times 2. And then, well, 2 times 2 plus 4, so 8 quantity squared. Okay, so from this we can say, all right, well, we have 3 times something and then times something. So if we were to focus on what's going on here, so we have 3 times 4 over 8, what fraction does that simplify to? 3 halves, good. And then what about the second one? So maybe if it helps to simplify the numerator first and see what cancels out after that. I take the pencil to mean you have it. So what would the fraction be?
For the second one,
Yeah, for the second one.
so,
If you need to use a calculator, you can use that.
yeah, plus 6 times 4 plus 24 times 2, so this 24 plus 48, and,
72.
72 over 64 is a fraction.
Yeah. So that simplifies too. So
5 over 8.
Yeah, 9 over 8. Good. Okay. So then what you notice is that on the numerator, all these factors here are odd, but on the denominator, all the factors here are even. So if you plug this all into a calculator or multiply the numerator and denominator separately, you should end up with 243 over 32 as your fraction. Okay? So any questions on that? All right. So now last example is going to be another good old find the equation of the tangent line. So let's do that. So in this case, we're going to need to break this up into our usual 3 steps. So remind me, what is the first step again? And then, right. So in this case, we have to find y prime of pi over 4, right? Okay. So based on what we've been doing up until this point, why don't you guys first figure out what the derivative is? And to give you guys a hint, cosine squared of x is the same thing as cosine of x, quantity squared. So why don't you guys take a second to find, or take a minute or two to find the derivative of that? Go ahead and reconvene then. So who has the derivative first off? Don't worry about plugging in x equals pi over 4 just yet. What would it be?
Is it negative times square root of x?
What's that?
Negative times square root of x?
Not quite. Remember, this is cosine of x quantity squared, right? So what would your inner and outer functions be first off?
So would the outer function be cosine of x or cosine?
Well, cosine of x is inside square, right?
Okay, so the inner function's cosine of x, and then the outer is x squared.
Yep. Okay. So in this case, your inner function is cosine and outer's x squared. So f prime of x is just 2x. And then consequently, that tells you that f prime of g of x is then just 2 times cosine of x. But on the other hand, well, g prime of x is just negative sine of x, right? So that should pretty quickly tell you that your derivative is then just, well, multiply these two together, so you have so in this case, you're multiply these two together to get your derivative is negative 2 cosine of x times sine of x. Okay? But the thing is that one nice thing about plugging in x equals pi over 4 is that if you focus on cosine and sine of pi over 4, you'll notice that they're the same values, right? So if you harken back to the unit circle, what are those two values equal to? Root 2 over 2. Good. So you have so equals negative 2 times root 2 over 2 times root 2 over 2. But then what do you notice? So on one hand, you have 2 divided by 2, so these cancel out. But wait a minute. Square root of 2 quantity squared is just 2. So these just cancel out with the 2 down here. So ultimately, you're just left with negative 1 as your slope. So all that's step 1. So that's that. So then step 2 is, well, find a point on the tangent line. Find points on tangent line. Okay. So if x equals pi over 4, well, then just plug in the point into the original function, so cosine squared. So we have y equals cosine of x, or, well, not just x here, pi over 4, y squared. But as we already established, cosine of pi over 4 is just root 2 over 2. So we have root 2 over 2 quantity squared, which that just simplifies pretty nicely to what? 1/2, because that's just 2 over 4, or 1/2. So then the point is then, well, pi over 4, 1 pi over 1/2. Alright. And then the last step is then, well, now we got our slope and we got our point, so just go ahead and plug this into the equation of tangent line. Okay. So if you were to plug this into our good old point slope form, then what should we end up with as our line? So right, in the form of y equals what?
Y minus 1/2 equals negative 1 times the quantity of x minus pi over 4.
Yep. So y minus 1/2 equals negative quantity x minus pi over 4. Okay. So then if you distribute the negative 1 and bring the 1/2 over to the other side, well, that should pretty nicely net you the point slope, or the not just the point slope form, but the actual equation of the tangent line, which should just round up to what? So if we were to just solve for y and distribute the negative 1, we should end up with what?
Negative x plus pi over 4.
Negative x plus pi over 4 plus 1/2. Yeah, again, the thing. Okay. Alright. So then this would be your final answer. So, any questions on that? Alright. Well, that's all I have for today, so I will see you guys on Wednesday. Hopefully the lights will be functioning by then. But, yeah. see you guys on Wednesday, and I'll have Zoom office hours tonight. Other than that, I'll see you guys on Wednesday.